a table with the adhesive tape, so that a portion of the paper protrudes outside the table. We fix the cardboard on this sheet of paper. Then, we place the lit torch on the table and adjust it in such a way that the streak of light from the rectangular slit is seen along the white paper. The rectangular slit should be at the center of the light beam from the torch. Finally, we place a small strip of mirror in the path of the light ray. So, what do you say?
The light ray strikes the mirror and reflects in another direction.
Right. Something like what you were doing in your game. The light ray from the source of the reflecting surface is called the incident ray.
So in this case, the light ray from the torch hitting the mirror is the incident ray.
That's right. The light ray that bounces off the reflecting surface in another direction is called the reflected ray.
Are you referring to the ray that is reflected back from the mirror?
Exactly. Let's continue with our activity. Now, we draw a line on the paper along the mirror to mark its position. We mark some points on the path of the incident ray from the torch to the mirror. Similarly, we mark the path of the reflected ray. Now, let's remove the torch, cardboard, and mirror and join the points. Can you see where these lines intersect?
Interesting. The lines drawn along the paths of the incident and the reflected light rays intersect at a point on the line we drew to indicate the plane mirror.
The point at which the incident ray strikes the reflecting surface is called the point of incidence. Next, we draw a perpendicular to the line representing the mirror at the point of incidence by using the set square. This line is called the normal. Can you see how the other lines form angles with the normal?
Yes, both the reflected ray and the incident ray form angles with the normal.
The angle between the incident ray and the normal is called the angle of incidence. It is represented by the letter I. The angle between the reflected ray and the normal is called the angle of reflection. It is represented by the letter R. Now compare the angle of incidence and the angle of reflection using a protractor. Which one seems bigger?
Neither. Both angles seem to measure the same.
Correct. That's because the angle of incidence is always equal to the angle of reflection. Now let's look at the second law, which states the incident ray, the normal at the point of incidence, and the reflected ray lie in the same plane. We will slightly modify the setup that we used in the previous activity. Consider the portion of the white paper that extends beyond the edge of the table. Initially, you can see that the reflected light rays are on this portion of the paper, right?
Right. Now, fold the paper downwards along the edge of the table. What do you observe? Can you see the reflected light ray on the portion of the paper that has been folded downward?
No, it is not visible now.
This is because the bent portion of the paper is now in a different plane. That is, the vertical plane. Thus, the plane of the reflected ray is different from that of the incident ray.
I get it. When the paper was spread straight along the surface of the table, it was on the same plane as that of the light ray incident on the mirror. The incident ray, reflected ray, and the normal, all the three were in the same plane. When the paper was folded, it went to a different plane, and so the reflected ray was not visible on that part of the paper. So that was the secret behind the trick James was playing on me?
Yes. Now that you know the laws, you can explore them and create tricks of your own.